What's up, Calc Gang? Today we're going to be iterating this region according to the value f of xyz is equal to xy. So how do we start this? Well, we need to decide which way we're going to go first. When we set up our triple integral, which is how we're going to solve this, we need to know we're going to do dx, dy, dz first. Which way are we going to go? So usually, if you can, you'd like to do dz first, because what you'll do is you'll get the z out of the way, and what you'll be left with is just x and y, which you must have already learned double integrals using x and y. So what it'll do basically is you'll just go back to something you already know how to do. So we're gonna look at this and we're gonna see if we can. And looking at it, yeah, it does look like we can. You see how z here, it starts at 0, and it goes up to a value that we have already nicely. Z is equal to 4 minus y squared. And what we can do with this is we can go ahead and write that down. So z goes from 0 to 4 minus y squared. And we're going to be doing, so we're going to do z simple. So we got this. So what we have left with is the domain of x and y. So what we're going to do is we're going to look at the y-axis, or the xy axis. xy axis. And then what we get when we do xy axis is we're going to set z is equal to 0. Therefore, and then we look at our equation here. Z is equal to 4 minus y squared. So we have 0 is equal to 4 minus y squared, which is equal to y squared is equal to 4, or y is equal to 2. And we also have this, y is equal to x. All right, so we're gonna graph these two things. We also know that x is equal to 0 and y is equal to 0 are also bounds because it's only in the front axis here. So we can also write down x is equal to 0, y is equal to 0. And if we graph all these things, we'll get a region that we also know how to solve. All right, so y is equal to 2. Y is equal to x. This point will be 2, 2. Y is equal to 0. That's just this. And x is equal to 0. So if we look and we have our area bounded right here, this. All right, so from our double integrals, we know how to find the thing of this. So let's start. We're gonna go y first. So y goes from 0 here, or no, never mind. Okay, so looking at this, if we go up, straight up from y, we're gonna see that y runs first into y is equal to x, and then it goes to y is equal to 2. So y is greater than x, but less than 2. And now we have to know where x goes from. So our x is, all we have left to do is where it starts and where it ends. So x starts at 0, and x ends at 2, which is this point here. So 0 is greater than x, greater than 2. All right, so now we look at what we got. We have this, we have these two. And with all this information, we can make our triple integral. So I'm going to erase a little bit. Actually, never mind. We're just gonna write it down here. So x is on the outside, 0 to 2. Y is in the middle, x to 2. And z is on the outside. Z goes from 0 to 4 minus y squared. And our value for f x, y, z is x, y. And then don't forget dz, dy, dx. And this is what we're going to be integrating. So this is the hardest part. We got it through the hardest part. Now we just have to integrate. And the integration is not going to be that hard, but it's a little bit of algebra, a little bit of math. It's the things that you like. 0 to 2, x to 2, and a z will come in here. X, y, z from 0 to 4 minus y squared dy dx. Integrate that out. 0 to 2, x to 2, x, y, 4 minus y squared dy dx. Minus 0, obviously, but that's nothing. 0 to 2, x to 2. So 4xy minus xy to the third dy dx. Now we got all this stuff out of the way. I'm gonna erase it. I'm gonna bring this up here. So we got 0 to 2 Now integrating with respect to y, for xy becomes 2xy squared minus xy to the fourth over 4 from x to 2 dx. So now we plug in this for y. It's gonna be big. How much space I got? I got all the space. All right, so writing this out, 0 to 2, we're gonna get 8x minus 4x, and then minus 2x to the third minus x to the fifth over 4. And this negative will go to here, and this negative will cancel out that. So now we're going to simplify our terms. 0 to 2, we get 4x minus 2x to the third plus x to the fifth over 4 dx. I forgot a dx up there. All right, now we can integrate this easy. 2x squared minus 2x to the fourth over 4, which becomes 1/2 x. Or not 1/2, x to the fourth plus x to the sixth over 24 from 0 to 2, which this is going to become 8 minus 8 plus 64 over 24. 64 over 24 is going to break down. Okay, obviously these 8s are going to cancel. 64 over 24 is going to break down to 8/3. That's the answer. 8/3. So that's how we evaluate our integral. So thanks for watching. Good luck on your calc homework, and subscribe for more Calc 3.